In the previous videos, you've learned how to create a parameter sweep with SweepMe and how to use the sweep editor. Today you will learn how to easily control many different measurement instruments simultaneously. Therefore, we will introduce you to the working principle of the sequencer. What is the sequencer? The sequencer determines the course of your measurement. The measurement procedures are defined by the arrangement of modules in a tree structure. Let's look at a simple example. We want to measure the IV curve of a solar cell under different temperature conditions and for a variety of wavelengths. Therefore, our setup comprises of a temperature controller, a monochromator, and an SMU. What is a module? The different modules offer ready-to-use interfaces for various types of devices and operations. You can add modules to the sequencer via drag and drop. These modules can either load instrument drivers or come with other functions. Afterwards, you can set up your device in the dialog of the module. If you want to know more about the working principle of a single module, check our previous video about creating sweeps. How does the alignment of the modules affect the course of the measurement? The sequencer interprets each module as a variation of set points. Each module can have an individual iteration range. Modules without a distinct parameter iteration, such as hold or logger, are still interpreted as a one-step iteration. Indented modules create nested iterations. That means the child module performs its entire iteration for each step of the parent module. Modules on the same indentation level are processed consecutively. The next module starts its iteration after the iteration of the previous module has ended. You can combine both ways of sequencing to create your optimal routine. Let's have a look at our example. We will mimic all devices using the modules sweep and loop. Thus, you can repeat it on your own without the need of the real devices. We set up a sweep over 5 different temperatures and 10 different wavelengths. Furthermore, we set up the SMU to measure a 40-point IV characteristics. The hold module is set to 5 seconds. Now, the routine is interpreted as follows. The temperature controller iterates over the temperature range. For each of the 5 temperatures, 2 sub-procedures are executed. First, the hold module performs its operation named wait for 5 seconds, which can be seen as a one-step iteration. Second, the monochromator iterates over all the 10 wavelengths. Moreover, the SMU acquires 40 data points for each of the 10 wavelengths. Respectively, we get 5 times 10 times 40 equals 2000 measurement points in total. We can track the behavior by plotting voltage, wavelength, and the temperature over the measurement index. Let us start the exemplary sweep. The first temperature is set up and the system waits for 5 seconds. Now the first wavelength is set up and we see how 40 voltage measurements are taken. Then, the wavelength changes. Let's speed up the video to see the result. After measuring all wavelengths, the temperature is changed. For the new temperature, again all wavelengths are measured. Now, we are at the end of our run. You can try to reproduce it with your own SweepMe installation. What is a branch? A root-to-leaf path of nested modules is called a branch. The root module of all branches is an invisible time module that logs the elapsed time in any measurement. In our case, the sequence comprises of 2 branches. The first branch is time, makefile, temperature, and hold. The second branch is time, makefile, temperature, monochromator, SMU. Each branch represents a measurement. The total number of branches equals the number of leaf modules that have no further indented modules. Here, the 2 leaf modules are the SMU and the hold module. When is a module active? At the beginning of the run, all modules are initialized. When entering a branch, all modules in the branch are configured and get active. When leaving a branch, all modules which are not needed in the next branch are unconfigured so that no set points are applied. The modules that remain active stay configured. In our exemplary case, it means that the temperature controller and the hold module are configured first and get active first. If the one-step iteration of the module hold has ended, it gets unconfigured since it is not needed in the next branch. In contrast, the temperature controller remains configured and the temperature setpoint remains applied since it is also needed in the second branch. When the second branch gets active, the monochromator and the SMU get configured and the first setpoint of their respective iterations is applied. What is a measurement point? Each setpoint combination of the modules in a branch defines a measurement point. At each measurement point, the measurement values of all modules in the branch are acquired. When are the modules read out? When all setpoints are applied and reached, the measurement is triggered for all modules of the active branch. Afterwards, all modules of the active branch are read out. This way it is possible to acquire data from multiple instruments at almost the same time. Since the sweep and loop module automatically come with your SweepMe installation, you can repeat all steps of this video without a real device. In the next video, you will learn more about the widgets which help you to monitor your devices and the progress of your measurement. You can download SweepMe for free on sweep-me.net. If you have any further questions or suggestions, feel free to text us via contact@sweep-me.net or leave a comment in the comments section below. Thanks for watching and feel free to subscribe if you like to get informed about the next video.